I quite like this topic. It's compound interest. So this is exponential growth, but just like biological populations grow, and the more rabbits you have, the more rabbits you get. The more money you have in your bank account, the more it grows. So here's to your money growing. Now, the pessimist version of this would be the more money you owe, the debt also grows. But let's think primarily positively about money you have. Okay, so how does annual compounding work? The amount of money you can expect to have is based off the principal. So A is amount, P is the principal. Okay, that's how much money you put in, times, well, you better get back your money, P times 1, at the end of the first year, and you better get back R, the interest rate, right? So if you put in $100 for P, you get that money back, P times 1, and then if the interest rate is 10%, right, if R, little r is 0.1, 0.1 times your principal is how much interest you get. Now, if you put it in for more than 1 year, essentially you're multiplying times 1 plus r repeatedly, right? So that's your equation. What if it's compounded n times a year? That complicates the formula a little bit. The amount is equal to the principal, but now you don't get the whole interest rate at the end of the year. You only get, let's say it's compounded 12 times a year monthly. You only get 1/12 of your interest rate, r divided by n, but you get it not only every year. If you put it in for 3 years, you don't get it 3 times. You get it 3 times for every month. So that would be 36 times, 3 times 12. So that's the compounding n times a year formula. I've got a quick example of both. Let's say you have $1,000 at 10% compounded annually for 20 years. How much will be there at the end? Now, 10%, that's roughly speaking what the long-term average of the stock market is. So if you put money in, obviously it could go down, but sort of long-term, that's over the last 75 years, that's sort of what's happened. So my amount is going to be 10,000 times 1 plus, right, 10% interest raised to the 20th, okay? So let's go over to something like Desmos. I'll tell you what that is in a moment. I'm doing a few calculations in Desmos today, I guess. 10,000 times 1 plus 0.1, all raised to the 20. Okay, so after 20 years, 10% interest, you're going to have $67,274.99.9. So 67,275. So 275, is that what it was? Yeah. Okay. Wow, that's, that's going to require a lot of patience, but 67 is a lot more than 10,000. Now, here's an example that I want to compare that to. Monthly compounding is happens, it grows at just a little bit faster than annual compounding. But if you can only get a 0.5% interest rate compounded monthly, how long will it take to grow $10,000 to $20,000? So where did I get that 0.5% interest? I just looked up online what the best interest rates are. So if you're opening a bank account today and you're just putting your money in, now there's no risk here. Stock market or something like that would have risk, but you're going to get about 50% APY. That's annual percentage yield. But let's just imagine some bank says, okay, we'll give you that and you can have it monthly. So the amount is, of course, supposed to start with 10,000, and we have 1 plus 0.050 divided by 12, right? And we're going to put that in for t times 12, right? Because we get that every month, okay? And we really want to know, hey, when does that come out to 20,000, okay? So look and see what we've got here. We've got an exponential equation. We're going to divide by 10,000 to start with. That gives us a basic exponential. So 2 equals 1 plus 0.05 divided by 12 raised to the 12t. How do you solve for a variable in the exponent? Well, isn't it a good thing you know logs? So we'll just take log base 10 of 2 equal to log base 10 of 1 plus 0.05 divided by 12. And remember, an exponent using the power rule can come down in front of the log. So it would be 12t here. Well, I want to solve for t. So what am I going to do? I'm going to have my log of 2, but now I'm going to be dividing it by those other numbers over there, right? Divided by 12 and divided by log of 0.05. Oops. Better do log of parentheses 1 plus 0.05 divided by 12. So much fun. That's how long it's going to take. So let's see if we can remember that. Log 2 over 12 log. So log 2 divided by 12 log of 1 plus 0.05 divided by 12. Okay, so that's wrong. That's way too soon. So let me go back and ask myself, why is that wrong? And this is part of the math process, right? Well, I look at this and I realize, uh-oh, I gave myself 5% interest. Yeah, 5% interest, about 13 years would be right. But you didn't get 5% interest. You got 0.5% interest because that's the best a bank is offering right now, right? So that's the number that we got. Ooh, okay, so let's see what happens. There we go. 138.65 years. Let's just round that to a nice, even, approximately 139 years. That's how long it would take $10,000 to go to $20,000 at 0.5% interest. Something to think about.